The second derivative test. This is a third video that relates to curve sketching. The first video, very long, showed you the fundamentals of the whole process. The second video helped you find absolute extrema values, absolute maximum or minimum values. And then this one is going to be the second derivative test, which is an alternative to the first derivative test you learned earlier. And you would say, what? I didn't learn a first derivative test. Well, you did. We just didn't call it the first derivative test. So I'll explain that as we go through here. But here's the concept of the second derivative test. You see that that is a maximum. Your eyeballs see that it's a maximum. And you used to say it's a maximum because f prime of x switches from plus to minus. In other words, your function went from going uphill to going downhill, and that makes a maximum. Well, the second derivative test is going to justify a maximum just in a different way, and it's going to basically use this idea. That maximum has a horizontal tangent, and it has a horizontal tangent during a concave down stretch. Anytime you have a concave down stretch with a horizontal tangent, you have yourself a maximum. Likewise, your eyeballs see that's a minimum. Anytime you have a concave up stretch and a horizontal tangent, you have a minimum. We used to say f prime of x switched from negative to positive. That's called the first derivative test. And the reason we called it the first derivative test is we referred to the first derivative. We want to see how the second derivative test, which is this thinking right here, can be put down on paper. So here it is. Keeping with the theme, I'm sticking with the same function that we've been using in these three videos. First and second derivatives. Secretly, that's what it looks like, but we wouldn't have access to that. And before we get into the actual second derivative test as it relates to this problem, here's the definition. A maximum occurs when the first derivative is equal to 0 and the second derivative is negative. Hey, right there, the first derivative is equal to 0, and the second derivative is negative because we're in a concave down stretch. Using the same logic, I see this as a minimum. It has a horizontal tangent during a concave up stretch. This is calculus talk for horizontal tangent, concave up stretch. It's important to know that the second derivative test can only be applied to interior points. So this is a, this is a minimum, but we just can't apply the second derivative test there. So based on what I just said, this is what it would look like in nitty-gritty number crunching. I would take a look, for example, if the question said justify all the interior extrema using the second derivative test. Well, the interior extrema would occur when the first derivative equals 0. They could occur when the first derivative is undefined, but then we can't use the second derivative test because second derivative test only works with horizontal tangents. So it's not necessarily universal. But if I would find out when my first derivative equaled 0, which we've done this already with this problem, now I take that x value, and I know I have a horizontal tangent there because the first derivative equals 0 there. I plug it into the second derivative, and remember the second derivative was 2x plus 1. I don't even care. Let's say this was too complicated for me to figure out. I don't care about a final answer to a number. I just care that it's positive or negative. And this is negative 6 plus 1. I know that's less than 0. Thus, I have a concave down stretch and a horizontal tangent, so I have a maximum. Concave down stretch, horizontal tangent, maximum. This is another spot where I had a horizontal tangent because it became from first derivative equals 0. I plug it into the second derivative, and it yields a positive result. So that means I'm in a concave up scenario, and I have to have a horizontal tangent, or I wouldn't have been working with x equals 2, thus it's a minimum. So there's the second derivative test. It's just a different way to justify maximums and minimums. You'd be tempted to ignore it and say, I'll just always use the other one, but there are times when there's not enough information to justify using the first derivative test, but there is enough information using the second derivative test. So don't ignore it, because it'll show up sooner or later in that way. See ya.